Hello everyone, this is Shivanshu Gupta. Welcomes you all to the Engineering Hotspot. So today we are starting a new lecture series on GATE 2023 detailed solution. So here in this lecture series, we are gonna provide you the detailed solution of all the important subjects of mechanical engineering that has been asked in the GATE exam. So first of all, here we are starting from the production engineering subject. So, so from now onward, one by one, we will cover the solution of all the important subject. So, if we discuss about the production engineering, so total this year, we can see that in the GATE exam, total 10 questions has been asked. And the weightage of all these 10 questions was total 17 marks. So that is why this becomes one of the very important subject from the GATE point of view. So that is why, first of all, we are covering the solutions of the this subject. So here, you can also purchase in our subject call our channel Engineering Hotspot the detailed class classes of production engineering. There, I have covered the entire syllabus of the production engineering in 96 lectures, 96 hours, and total 66 lectures are there. So that is what you can purchase from there. And now we are starting the uh, detailed solution of the GATE 2023 production engineering. So here is the first question here that you can see that uh, a cubical part has to be accurately positioned first, arresting 6 degrees of freedom, and then clamped in a fixture to be used for machining. Locating pins in the form of cylinder with hemispherical tips are to be placed on the fixture for positioning. Four different configuration of locating pins are proposed as shown. Which one of the options given is correct? So here you can see that a cubical part is there which has to be positioned by arresting the 6 degree of freedom with the help of clamped fixture. So this question is from the jigs and fixture topic, and here you have to arrest all the 6 degree of freedom with the help of the clamping, right? So you see four different figures we have given. So in each of the different figure, different clampings are there at different surfaces. So here in the first surface, you can see that first figure. So basically, three different surfaces and total 6 pins are there. And in the second configuration, you can see that 4, 2, 6, 7. 7 pins are there. In the third configuration, total 5 pins are there. In the fourth configuration, total 8 pins are there. So out of that, we have given some of the options, and from those options, we have to decide which configuration is best for arresting the all the degree of freedoms, right? So for that, what we can do, we have to follow the 3-2-1 principle of location. That is also called the 6 point location principle. So in this principle, in the 3-2-1 principle of location, so basically what we do, we arrest the 6 degree of freedom with the help of 6 different pins in the different surfaces. So here you can read that uh, the 3-2-1 principle of location is used to constrain the movement of the workpiece along the three axes x x y y and z z. So with the help of this principle, what we do, we actually try to constrain the degree of movement of the any workpiece in the three different axes. How this is being achieved? So this is being achieved by providing 6 locating pins, 3 pins in base plate, 2 pins in vertical plate, and 1 pin in the plate which is perpendicular to first two plane. So basically how we do that? So 3 pins we are using in the base plate. So if you see your first figure, so here you can see that we are using the 3 pins at the base. In the second figure, we are using the 4 pins at the base. In the third figure also, we are using the 3 pin. In the fourth figure, we are using the 4 pins. So out of that, what we can see that there are two figures. in which we are using the three pins, right? So that's why the config. So that's why what we can say that only figure either configuration P1 will be right or configuration P2 will be right for the constraining the 6 degree of freedom. So you see that next what is written, two pins in vertical plane. So here you can see that in the vertical plane, so this is your vertical plane, and on this vertical plane, so this is your vertical plane, and here in this vertical plane you can see that two pins has to be there. So here in the figure one you see that two pins are there, right? So that's why finally what we get, so in figure configuration 2 also two pins are there, in configuration 4 also two pins are there, but as from the first case that it has to be there three pins at the base, so that is why the we can neglect this and right now this also. So we are left with only configuration P1. So here in the configuration P1, and along with that, you can see that in the 3 to 1 principle, one more option is there, that is one pin in a plane which is perpendicular to the first two plane. So here two planes, one is the vertical one, second one is the horizontal one. So this is your third plane that is perpendicular to the both the plane, and there we have to make one pin fixed. So this is how we can say that total 3 2 1 principle has been followed. So that is why the configuration P1 arrests 6 degree of freedom, while configuration P2 and P4 are over constraint and constraint P3 is under constraint. So here you can see that that is why this option A will become your right option, where the configuration P1 is the arresting the 6 degree of freedom, while P2 and P4 are over constraint. By P4 and P2 are the over constraint because you can see that totals 3 plus 2 plus 1, that is 6. So here you see that 4 plus 2, 6 plus 1. So total 7 pins are there. Here also 4 plus 2 plus 2, that is 8 pins are there. So that is why they can be said as over constraint. And P3 you see only 3, 4, 5. 5 pins are there. So that is why this can be called as the under constraint configuration. So that is why finally what we got to know that, so only figure configuration P1 that is doing following the 3 to 1 principle of jigs and fixture, or we can say 3 to 1 principle of the fixing of or arresting of 6 degree of freedom. So that is why this is our first question that is being asked in the GATE exam. This question is being asked for the 1 mark, and the options are given, 4 options are given, we have to select one option. So this is, I guess, very easy question. Who knows the 3 to 1 principle of jigs and fixture can easily solve this question. So now what we are going to do, we are going to go for the next question. So here this is again 1 mark question that is being asked in the GATE exam. So here you see that two surfaces P and Q are to be joined together. So here two surfaces are there, P and Q, that are being joined together. In which of the given joining process there is no melting of the two surfaces P and Q for creating the joint? So basically in this question it is asking that two surfaces are there that are being to be joined, and uh, when these two joints when these two surfaces has to be joined, so there should not be melting of the surfaces, right? So we have to create a joint in between these two material in such a way that there should not be any melting of the uh, both the part. So we have given 4 options. One is the arc building, second one is the brazing, third one is the adhesive building, and last one is the spot building. So out of that we have to select the options which are correct with respect to the given condition that melting of the two parts should not take place. So here you see that option number A, that is the arc building. So here you can see that in the arc building, you see here the melting of the part is taking place, right? Here we are supplying the heat with the help of this electrode from the AC or DC power source. So as we are supplying the heat, you can see that the melting of the part is taking place. So that definitely be what we can say that our option number A is wrong, right? This is what we can say. Now if we go for the spot building, you see spot building also, That is also called the resistance welding. So in the spot welding, what we do, we use the resistance heating. So with the help of resistance heating, what we do actually, here one at the contact point of the two metals, the welding is being generated, and here we are using first of all the electricity, and after that we use the force to make the joint. So here also we can see that some amount of melting of the two metals are being taking place, right? So that is why what we can say that the spot welding also is a welding in which melting of the two parts take place. Now we are remained with the brazing and adhesive bonding. So if we go for the brazing, so here in the brazing you can see that brazing is a joining process in which a filler metal is placed between the faying surfaces to be joined, and the temperature is raised sufficiently to melt the filler metal, but not the component, as would be the case in fusion welding. Thus, brazing is a liquid solid state bonding process. So, this is what kind of joining process is this? In this joining process, we use the one filler material, and that filler material has the melting point much below than the parent material that we are used to joining them. So that is why brazing is one of the process in which melting of the surfaces does not take place when we join two different surfaces. So that is why this become our first option that is being correct. So here what we can say, option number B is right. Now if we go for the option number C, so that is the adhesive bonding. So in the case of adhesive bonding also, we know that what we do actually, we apply adhesive in between the two surfaces that are being to be joined. So that's why there also there is no melting of the surfaces take place when the welding is being done. So that is why these two, option number B and option number C, becomes the right option. Hello, Suraj. So that's why option number B and option number C become our the right option. So this question was the multiple option question in which two or more options are the correct one. So if you have selected only one option, then it will become a wrong answer. So that's why the option number one, that is your arc welding, that is the wrong option, and the fourth option, that is the spot welding. This is also the wrong, because in these two options, melting of the surfaces are being taken place. But in the case of B and C, where brazing and adhesive bonding is taking place, so there is no melting of the surfaces. That is why these two options are correct for this question. And this is for the 1 mark question. Now let's go to the third question. So in the third question, you can see that this was also asked for the 1 mark question. So what is there? In a metal casting process, to manufacture parts, both patterns and mold provide shape by dictating where the material should or should not go. Which options given correctly describe the mold and the pattern? So basically, this question was from the casting topic, and in this topic, this in this question it is being asked, we have to select one option or multiple option which are being correct related to the mold and pattern. So here you can see that in the question it is saying that in a metal casting process to be manufactured part, both pattern and mold provide shape by dictating where the material should or should not go. So we have to decide actually where our materials will go, can go, or where our material cannot go by reading our different options. So you see, first of all, mold walls indicate boundaries within which the molten part material is allowed, while pattern wall indicate boundaries of the region where mold material is not allowed. So you see that here in the option number one, what we can see that mold walls indicate boundaries within which the molten part is, material is allowed. So yes, we know that in the case of casting, when we do the casting, so what we do, we use one mold, and inside of that we place one pattern, right? So here in the mold cavity, so this is your mold cavity, this is your mold, and this is your cavity, and this cavity is being made by with the help of the pattern, right? So this option is saying, mold wall indicates boundaries within which the molten part material is allowed. So yes, so mold walls are allowing the uh, molten metal to come inside of that, right? So that's why this option. And next, what is written? While pattern wall indicate boundaries of the region where mold material is not allowed. So you see that what actually pattern boundaries are doing. So pattern boundaries are used to make the cavity. And if the mold material is allowed to come inside of this uh, cavity, then what will be there? We will not be able to produce the required shape that we want to produce. Right. So that is why what we can say that the mold cavity, so this option become actually the right option. Why? In the first part, this option is saying that mold wall indicate boundaries within which molten material is allowed. So yes, molten metal is allowed in this cavity, so that is why this is right. And while pattern wall indicate boundaries of the region where mold material is not allowed, so here inside of this cavity mold material is not allowed. If the mold material will come inside of the this cavity, so what will happen? So we will not be able to get our the required product. So that's why this is option number A is right. Now you go for the second option. Mold can be used to make pattern. So yeah, we all know that mold can be used to make the pattern. So option number B also become the right one. So that now if you read the option number C, pattern wall indicate boundaries within which molten part material is allowed. So what? Pattern wall indicate boundaries within which molten part material is allowed. No, this is not right. So within the cavity, we cannot allow the molten material to come inside. So that's why this option number C becomes the wrong option. Now, if you go for the last option, that is the option number D. So patterns can be used to make the mold. Yes, patterns can also be used to make the mold. So that is why this option number A, B, and D, these are the three options that are correct. So this question was also for the multiple choice question, multiple option question. So here this was also asked for the 1 mark. So total three questions are being asked for the 1 mark and seven questions are there. Here you can see that total 10 questions has been asked. So out of that, seven questions, that is of total 14 mark. So 14 marks is for the seven from the seven question and 3 marks for from the three one number question. So total 17 marks question has been asked this year in the GATE exam. So that is why I am again saying that this production engineering subject is very important from the GATE point of view. And you can see all our production engineering lecture by subscribing our channel Engineering Hotspot, and you can purchase the package of the production engineering subject also only at a cost of 299 rupees. So at a cost of this you can purchase the subject and you will get all these lectures of from all the topics in a detailed way. So I have covered there. So now let's go to the next question, that is the question number 4, and this question is being asked for the 2 marks. So here you see that what this question is saying, in a orthogonal, in an ideal orthogonal cutting experiment, the cutting speed V is 1 meter per second. So we have given cutting speed V, that is 1 meter per second. The rack angle we have given alpha, and this rack angle alpha value is given as to be 5 degree. Then the shear angle we have given, and this shear angle is 45 degree. Now, applying the ideal orthogonal cutting model, consider two shear plane, PQ and RS. So basically here you have to go for the figure. So applying the ideal orthogonal cutting operation, consider two shear plane, PQ. So this is your PQ plane and RS. So this is your RS plane close to each other. As they approach the thin shear zone, plane RS gets sheared with respect to PQ. So basically, with the help of this tool, what we are doing, we are shearing of this RS plane with respect to PQ plane. Now, assuming that the perpendicular distance between PQ and RS is delta. So this delta we have given, basically this is the shear plane length that is given us to be 25 micrometer. What is the value of shear strain rate? That is what we have to find out, and its unit is second inverse. So that the material undergo at the shear zone. So if I talk about this question, so what in this question it is asking? This question is from the ideal orthogonal cutting, in which we have given the cutting speed of 1 meter per second. Rack angle we have given alpha. Shear angle also we have given, that is of 45 degree. And now what we are and one more thing we have given, shear plane thickness we have given, that is delta, and this is given by 25 micrometer. Now we have to find out the shear strain rate. So what is the equation for the shear strain rate? So that is very easy. V shear strain rate is given by Vs divided by delta. What is Vs? So Vs is the shear velocity, and this delta is the thickness of the shear plane. So with the help of this Vs by delta, we can find out the value of the shear strain rate. Now, here delta value we have given directly. What we don't know the value of Vs. So if we will manage to calculate the value of Vs, we can easily have the shear strain rate. So how we can calculate this Vs? So you see that we have another equation to find out the Vs value, that is called the shear velocity. And this is given by V, that is cutting velocity, into cos alpha divided by cos phi minus alpha, where phi is the shear angle. So now when you will put all the value, so we have given V is equal to 1 cos alpha means 5 divided by cos 45 minus 5. So if we will put all the values here, we will get the shear velocity, and this shear velocity is coming out to be 1.3 meter per second. So now we have the shear velocity that is given by 1.3 meter per second. Now if we will put this shear velocity 1.3 meter per second, so we will get the final answer, and the final answer will be, what is the shear strain rate? This shear strain rate is given by Vs divided by delta, and Vs is 1.3 divided by delta value is 25 micrometer. So if we convert the micrometer into meter, so we have to multiply by 10 to power minus 6. Now after putting all this value, we will have our final shear strain rate value, that is given by 5.2 into 10 to power 4 second inverse. And that's why this option number B becomes our right answer. So this is quite a straight question for the 2 marks that is being asked this year. And here you just need to find out the value of shear velocity, right? So once you got the value of shear velocity, just you need to put this value into the final equation of Vs divided by delta, and you will have your shear strain rate. Now let's go for the next question, that is question number 5. So here this question was based on the CNC machining. So in this question, what we can see that a CNC machine has one of its linear positioning axis as shown in the figure, consisting of motor rotating a lead screw, which, which in turn moves a nut horizontally on which a table is mounted. So a CNC machine is there. So a CNC machine has one of its linear positioning axis as shown in the figure. So this is its linear positioning axis, consisting of motor rotating a lead screw. So here one motor is there that is rotating this lead screw now, which in turn moves a nut horizontally on which table is mounted. So here you can see that on this lead screw, one nut is there, on that one table is mounted. Now the motor moves in discrete rotational steps of 50 step per revolution. So this how this motor is running? This motor is running 50 times. Okay, 50 steps per revolution, right? So this motor is running 50 steps per revolution. The pitch of the screw is 5 mm, and we have given the pitch value, that is of 5 mm. Now The total horizontal transverse length of the table is 100 mm. So total how much distance we have to move this table? So we have to move this table for the 100 mm. Now we have to find out what is the total number of controllable locations at which the table can be positioned on the axis. So basically we have to find out how many steps we are required to move this 100 mm distance to this table. So how we can find out that? Now you see here, first of all, what we have given, the motor moves in discrete rotational steps of 50 steps per revolution. So it means in one revolution, this motor is taking 50 steps, right? Now the pitch of the screw is given 5 mm. What is pitch? The total length traveled in one rotation. Okay. So in one rotation, whatever the distance that we cover is called the pitch. So here you can see that what we can say, and in one revolution it is taking 50 steps. So, so for moving the 5 mm, so for moving the 5 mm, how many steps we require? We require the 50 steps, right? To move 5 mm, because whatever distance we are traveling in one revolution is given by pitch, that is 5 mm, and in one revolution how many steps are there? 50 steps. So that is why we can equate this to 50 step is equal to 5 mm. Now what is the number of steps that we are required for the 1 mm? If we will manage to calculate that, then we will have the, we can calculate for also for the 100 mm, right? So for 1 mm, for 1 mm, we require how many steps? 50 divided by 5, that is 10 steps. So for one to move the table for 1 mm, we require the 10 steps. So that is why to move this for the 100 mm, so for moving this to the 100 mm, we require 100 into 10, that is 1000 steps, right? So we need to move our table by the 1000 steps to have the 100 mm of movement. So this was also very easy question. Just you need to understand how is the relation between the pitch and the number of revolution. If you got that, then this is the simple mathematics that you have to do solve this question. Now let's go for the next question. That is the question number 6. So in this question number 6 also, this question is basically from the material science. I have included in the production engineering, but this is basically from the material science. So the atomic radius of a hypothetical face-centered cubic metal is under root 2 by 10 nanometer. So we have given atomic radius R value, that is under root 2 by 10 nanometer. The atomic weight of the metal we have given. So atomic weight of the metal, that is basically atomic weight is represented by am. So this is 24.092 gram per mole. Then taking Avogadro number, so we have given Avogadro number also, and this Avogadro number is given by 6.023 into 10 to power 23, right? So this is the value for the Avogadro number, and this is atoms per mole. Now we have to find out the density value in the kilogram per meter cube. So how we can calculate that? So the equation for calculating the density is given by n. N is what? Number of atoms multiplied by atomic mass divided by Avogadro number into volume of the unit cell. So volume of the unit cell. Now, how we can calculate the volume of the unit cell? So volume of the unit cell can be calculated So volume of the unit cell can be calculated with the help of the. So you see, we have given the condition of the face centered cubic. So for face centered cubic, this volume will be given by a cube. And for the face centered cubic, we know one relation in between a and r. So this relation is given by how? This relation is given by 4 by under root 2 into r. So if we put the value of r here, so we can get the value of our a cube also. So now we will do the same thing. We will put here. So 4 divided by under root 2, 4 divided by under root 2 into under root 2 by 10 cube, right? So by putting this value, we will get the unit cell volume, and this volume is coming out to be 0.064 nanometer cube. Now we got the volume of the unit cell, and now we will put this value here to get the rho value. So rho, and how many number of atoms are there for the face centered cubic material? That is 4, right? So 4 into what is the atomic mass we have given? 24.092. Now you do one thing. Here we have given the value in the gram per mole, and we have been asked in the kilogram. So you convert this into kilogram by multiplying 10 to power minus 3 divided by. So Avogadro number is 6.023 into 10 to power 23 into 0.064. Now you see, if you want to convert this 0.064 in nanometer cube into the meter cube, so how, what you have to do? You have to multiply this by 10 to power minus 9 cube. By cube, why cube? Because we are here using a cube, or we are putting for the volume of the unit cell. That is why we have to put this 10 to power minus 9 into the as a root, as a power of 3, right? So when you will put all this value, you will have the rho value, and this rho value is coming out to be 2500 kilogram per meter cube. This is your final answer, 2500 kilogram per meter cube. This is your density value. That is what we have to find out in this question. So this question was also quite a straight question. You just need to put the values and you will have that. Now let's go to the seventh question. That is being, this is question is also from the material science, and this is being asked for the 2 marks. So total this year, what we can say, total 4 marks question is being asked from the material science, right? Along with 13 marks from the production side. So you see that a steel sample with 1.5 weight percentage carbon, no other alloying element present, is slowly cooled from 1100 degrees centigrade to just below the eutectoid temperature, that is 723 degrees centigrade. A part of the iron cementite phase diagram is shown in the figure. The ratio of pro-eutectide cementite content to total cementite content in the microstructure that develops just below the eutectide temperature, we have to find out. So basically what we have to find out in this question, we have to find out the ratio of the pro-eutectide cementite content to the total cementite content in this figure. So this is uh, one diagram we have been given iron carbon diagram, and in this iron carbon diagram we have to find out one ratio in between the pro-eutectide cementite content to the total cementite content. So and here one more thing we have given, that is a steel sample with weight 1.5 percentage, right, carbon, that is being cooled from the 1100 degree centigrade to the 723 degree centigrade. So what we will do, first of all, we will find out what is the mass fraction of pro u eutectoid cementite, right? So first of all, what we will do, we will try to find out the mass percentage of pro eutectide cementite. And how this we can find out? So we can find out this by m is equal to, we will give this m1. Okay, so m1 will be is equal to what? 1.5, that is the weight of the carbon, that is that we have given, minus 0.8, that is the eutectoid composition, divided by 1 6.7 minus 0.8. So this will give you the M1 value, that is the mass fraction of the pyrrhotectide cementite. So what we have done, 6.7, what is the maximum percentage of carbon minus the eutectide composition, and this will come on your denominator, and in the numerator this is given by 1.5 minus 0.8. So what is the M1 value? This M1 value is coming out to be 0.1186. Now we got the mass fraction of eutectoid cementite. Now what we will do, we will find out the value of mass fraction of total cementite. So this is the pro-eutectide cementite content. Now we will find out the mass fraction of total cementite. So what is the mass? 0.035 divided by 6.7 minus 0.035. Now you see why we have taken this time 0.035. So why we have taken that? Because okay, now you see why we have taken 0.035, because here you see that this we have given composition, we have to find out at 723 degrees centigrade. So we are trying to find out the total cementite content up to here. What is the percentage of that? Right? That is what we are trying to find out. So this we can find out with the help of the 1.5 minus 0.035 divided by 6.7 minus 0.035. This will give us the mass fraction of the total cementite, and that is given by 0.2198. Now what we will do, we will find out the value of m1 by m2, or and this value is coming out to be 0.1186 divided by 0.2198. So finally what we get? We get the final value of 0.54. So this is our final answer, that we have find out the mass fraction of the cementite content in the pro-eutectide mixture divided by the total mass fraction of the cementite. That is what we have find out, and their ratio, final ratio we have to find out, that is given by 0.54. Now let's go to the eighth question. Okay, this is an optical. This question is based on the optical flat, where it is being used to measure the height difference between the reference slip gauge. So here two slip gauges are there, gauge A and gauge B, and one optical flat is being used to find out the height difference. Upon viewing by the optical flat using monochromatic light of wavelength, so we have given wavelength lambda is equal to 0.5 micrometer. 12 fringes were observed over a length of 15 mm of gauge B. So we have given total n is equal to 12 fringes for 15 mm thickness of this or 15 length of this gauge be? If the gauges are placed 45 apart, the height difference of the gauges we have to find out. We have to find out the value of height difference of the gauges in the micrometer. Basically, this question here, we have to find out the final value in the micrometer. So this is what we have to find out. So you see, there is one direct equation to find out the height difference, and that is given by n lambda L divided by 2. Here, L is what? L is the difference between the two gauges, that is 45 right? So just you need to put all the value in the same unit and you will have your answer. So we have given 12 by 15, that is 12 by 15 multiplied by lambda is what? Lambda value we have given is 45 sorry, lambda value we have given 0.5. Lambda value we have given 0.5. Now this value you can see that we have given in what? Micrometer. You remember that. Now next we have given L, that is 45 divided by 2. So you see 45 is also in right? So this 2 will be cancelled out. Now if you will solve this, you will have H, and that this is given by 9 micrometer. Why 9 micrometer? Because units are cancelled out. So we are remained only with this lambda value unit, that is micrometer. So that is why H value is given by 9 micrometer. Clear? So that is quite a straight question. Just you need to put use this equation L lambda L by 2, and you have to put all the value, you will have your final answer. Now next, you see this is very good question and still very easy question. So you see that a solid part of polymer material is to be fabricated by additive manufacturing. So this material is being prepared by the additive manufacturing process in a square shaped layer starting from the bottom of the part working upward. So basically what you see here, this is one cubical shaped body is there that is being prepared with the help of this additive manufacturing method. And in this additive manufacturing method, what we are doing, we are using a nozzle of diameter which is given by A by 10 and the nozzle follows a linear serpentine path parallel to the sides of the square layer with a feed rate of A by 5 per minute. So basically we have given the feed value, and this is given by A by 5 per minute, and nozzle diameter we have given. The nozzle diameter value is A by 10 Now we have to find out the value of time taken to fabricate this part in minutes. So what we have to find out? We have to find out the time taken to fabricate this complete product. So how we can find out this? So this is very simple question. You need to just follow the basic mathematics to do that. So you see here, suppose we are starting from here. Okay, so here what we are doing, we are putting the material with the from the nozzle, outlet of the nozzle, and that nozzle diameter is what? Nozzle diameter is A by 10. So slowly the spots will be created here, and each will have the diameter of what? Each will have the diameter of A by 10. Now here in this direction, feeding will be there. And how the feeding is being done? This is being done by A by 5, right? So feeding is being done by A by 5 and A by 5 per minute. Now this is how, and again when this one layer will be deposited, then next layer will come, and this next layer will have the thickness of A by 10. So this is how in this direction also what we are doing, we are putting the a by 10 how we are moving by a by 10 distance, right? And in this direction also a by 10, and in the vertical direction also. Only in this direction we are moving by a by 5 path, that is the feeding distance, right? So now what we will do, we will use our basic mathematics to find out the total time taken. So first of all, we will consider the bigger chunk. So in this bigger cube, you can see that how we will find out the value. So here what we are doing, we are giving this a, this is b, this is c. Now the time taken for a will be is equal to what? So this is the total length, that is 3a. This. So this length is 3a. And how this will be covered? This will be covered by a by 10. Okay. And then what we will do? Then multiplied by again this this side distance. This side distance is 3a, and this side distance is covered by a by 5 distance in each step. Now the next upward distance, height will be covered. Height is given by 1.5 a divided by a by 10, right? So this is how we will cover the entire material. This is how we will deposit this. So first of all, we have deposited one layer, and how this layer is being deposited with the help of 3a into 3a. And this 3a, each of this distance is covered by how many steps? Each step of a by 10 length. And how this length is covered? Each step of a by 5 length, right? So now when you will calculate this, you will have the ta value, and this ta value will be given by 30 into 15 into 15, and this is total given by 6750 minute, right? So this is how this will be filled out. Now you go for the next layer, that is the b layer. So here you can see that again, this is how we will move, and this is, we will cover a by 10 distance, right? And here we will cover a by 5. So we will follow the same procedure to find out all the values. So TB will be is equal to what? TB will be is equal to 2a divided by a by 10 multiplied by 2a divided by a by 5 multiplied, height is a divided by a by 10, right? So here what we can say, two dimensions are being covered by a by 10 and one dimension will be covered by a by 5. So now when you will solve this, you will have TB value, and this TB value is coming out to be 2000 minutes. Now the last layer, last cube, that is TC, and TC will be given by a divided by a by 10 multiplied by a divided by a by 5 multiplied by 0.5 a divided by a by 5. So now when you will solve this, you will have the TC value, and this TC value is coming out to be, so the TC value is coming out to be 250 minutes. Now you need to add all that TA to get the total time. So total time TT will be is equal to TA plus TB plus TC. So this sum is coming out to be 9000 minutes. Now next, we are going to the last question that is being asked this year. So this question was based on the CMM machining. So a coordinate measuring machine is used to determine the distance between the surface SP and surface SQ. So one cube is there, actually one cuboid is there. And on this cuboid, uh, so what we are actually doing on this cuboid, two surfaces are there. One is the bottom surface SP and another surface is SQ. Now what we have to find out, so we have to see the surface SP is declared as the bottom as per the engineering drawing used for manufacturing of this part. The CMM is used to measure 4 point P1, P2, P3, P4 on surface SP. So how we're doing, basically with the help of CMM machining, we are measuring the distance of the, or the coordinates of the 4 points on the surface FC, SP. Similarly, on the surface SQ also 4 points coordinates are being measured. And here you can see that in the figure, the coordinates of all the points we have given. Now, if suppose we are connecting all these points, so we will have one surface. Similarly, here again we will have one surface, and we have given the coordinates of all the surfaces also. So we have to find out the distance between two fitted plane. So we have to find out the distance in between the SP and SQ. So here you can see that if you closely observe the P1 to P4 point, so all will have the y-axis coordinate as 0, right? 403, 306, 1.507, 202. So here you can see that in all the point y coordinate is 0. If y coordinate is 0, it means what we can say, this is the xz plane, right? So if we will manage to get the distance of the y coordinates of q1, q2, q3, q4, we will have the distance in between the SP and SQ. So what is the y coordinate distance of the Q1 point? That is 6. What is the y coordinate distance of the uh, Q2 point? That is again 6. What is the y coordinate distance of the Q3 point? 4. And what is 4? That is again 4. Now, the distance that we have to put here is average of all this. So average of all 6, 6, 4, 4 will be 5. So this is 5 mm basically. So this 5 mm is the answer for this question. So in which what actually we have done, we have observed here that this is z axis. So that is why the distance will be in the y axis. That is given by this side. So that is why we have taken the distance of the coordinates of all the points for the y axis. And this is our final result after taking the average of 6, 6 and 4, 4. That is 5 mm. Okay, so this is it for today. So we have covered all the questions from the production engineering. Now in the next class, we will cover the questions of the other subject, other important subject that has been asked for the GATE exam. So thank you for watching this. Goodbye.